versus voltage magnitude for the sine wave we are going to find. What exactly, how your sinusoidal signal, it will be vary from 0 to 90 and 180 and 270, it will be vary up to 360. One full cycle we are going to consider from 0 to pi by 2, like that we are going to consider pi 2 pi like that, so that we are going to differentiate different angles. Okay, we are going to take samples with respect to each and every 30 degrees. Why? Because we cannot take only 4 samples or 5 samples because of we are not getting clear waveform. Okay, in order to get a clear waveform, we are going to take 0, 30, 60 difference. We are going to take the angles. If you want, you can take 0, 15, 30 like that also you can take, or else 0, 10 like that also you can take. If you are going to take like that, you will get a exact sine wave, exact curve you are going to get. Okay, if you are going to take like this, almost you are getting like this. Like this you are going to get. That is why if you want, you can take the degrees will be vary from 0, 5, 10 like that also you can vary, or else for example I have shown this 0, 30, 60 I have shown the angles, and this will be sine theta, means degree we are going to substitute sine 0, 0, sine 30 1 by 2, sine 60 1 by root 2, like that we are going to find the value for the theta, means angle we are going to find the value. Then V out, we have a relation that V out is equal to 5 plus 5 into sine theta. Why we are going to take sine theta into 5? Again we are going to add 5, because we are going to take a signal is vary from positive plus or minus. We are going to take a 10 volts peak to peak. 10 volts peak to peak means we are going to take plus or minus 5 we are going to take. That is why we need to multiply by 5 and we are going to add with a 5. Okay, that is your formula to find output voltage. V naught is equal to magnitude of a voltage, means we need to find a positive peak as well as negative peak. Based on that we are going to substitute this 5 volts plus 5 into sine 0, means sine theta we are going to substitute. If I am going to take sine 0 will be 0, 0 into 5, 0, 5 plus 0 you will get 5. Again 5 volts into 5 volts into 0.5 you will get 2.5. 2.5 plus 5 you will get 7.5. Like that we are going to get the value. This is your output voltage. Why we are going to find these values? We need to find some hexadecimal values. That is why we are going to take this. Now value sent to the digital to analog converter, that is decimal value we need to find by make use of this. For that we have a voltage maximum into 25.6. Voltage maximum means this is the voltage maximum what we are going to get. This is a 5 and we are going to multiply with this by 25.6. What is this 25.6? What is your decimal number will be vary from 0 to 255. Totally how many counts we have? Totally 256, right? The decimal number is from 0 to 255. Totally how many bits we have? How many count? What is the count of that range 0 to 255? Totally 256 count. We are going to take 10 volts peak to peak. Divided by 10 means you will get 25.6 we are going to get. That is why you are going to make multiplication of 25.6 with this number. You are going to get this number. After finding this number, okay, this table is very, very important. You need to identify this decimal values. Okay, once if you are going to find these values, we are going to fit that values in the program. That is why we need to find these values. Got everyone? Any doubts?
No, sir.
Okay. Then next coming to the verification of the given values. Okay, for 30 degree and 60 degree we are going to verify the values of this table. Now V out is equal to 5 plus 5 into sine theta. Sine 0 will be sine 0. What is the sine 0? Sine 0 will be sine 0 is 0. For first value you are going to get a 7.5. For sine 30 we already know the value of sine 0. For sine 30 we are going to find the value. Sine 30 will be 0.5. Then 0.5 you are going to multiply with this 5, you will get 7.5 totally. Okay, then DAC output value 7.5 into 25.6. If you are going to multiply this 7.5 into 25.6, you will get 192 decimal value I am going to get. Next I am going to vary for the next value, that is your sine 60, that is 0.866. For 0.866 what you will get, if I am going to multiply 5 into 0.866 plus 5, you will get 9.33. This value will be 4.33. Plus 5 you will get 9.33. If I am going to multiply with this for the last column 25.6, that voltage maximum into 25.6, you will get 238 of your decimal value you are going to get. This is the verification. Okay, next we have a program. See, before going to program, make a note of this table. Make a note of this table and verification. Okay, verification I have shown only two. If they will ask for 10 marks, you have to show for all the values. For all the values, you have to show. Sometimes they will ask, the degree will be vary from 0 to 30. 30 degree difference they will ask, 15 degree difference they will ask, or 10 degree difference they will ask. For each and every one you have to find. If they will ask for 30, you find for same. If they will ask for 15, again the table will be increased 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180. Like that it will be keep on varying. It will be changed the table. Table will be changed. Got everyone? Any doubts? It's a very important topic. Any doubts?
No, sir.
Okay, please make a note of this. Then verify all the numbers. Verify all the degree means 0, 30, 60. You have to verify all. Then we'll go with the program. Then after this, I will give an assignment. Now you have to perform that assignment. See, in the lab, you have to perform this program. It is there in the practical. The interfacing, you have this lab. This is a C program. That we'll discuss later. You make a note of this table and find the values for each and every one. Any confusion with this 25.6? You know how you got 25.6? The decimal value will be vary from 0 to 255. Hexadecimal maximum count 255. 0 to 255. How many number we have? Totally 256 count. If I am going to divide it by 10, why we need to divide it by 10? Here we are considered as a peak to peak 10 volts we are going to consider. That is why we are going to divide it by 10. 10 volts peak to peak if I am going to consider divided by 255 by 6. If 10 I am going to take, it will be 225.6 we are going to get. If you know all these things, easily we can perform this. Over. Should do both verification also. ಆಯ್ತಾ?
Yes, sir.
Yes, sir.
Okay. Next, do the verification for each and everyone. Okay, shall we discuss the program? Can you trace the program? See here, move dptr comma as table. What is this table? I have defined here the table dB data byte with respect to 128, 192, whatever the values we found to generate the sine wave. These values I'm going to fit it in the table. Okay, this is my table. I'm going to initiate the table dB. This is the instruction data byte. We are going to take 128, 197, 192, or 238, 255, like that, so on. All numbers, all the values I am going to fit here. Okay, that is your table. Now move R2 comma as count. We are going to load one value as a counter. Okay, R2 will be your counter. What is the value I need to give? How we are going to decide the value? Here we have to calculate how many number of steps we need to perform. Okay, totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Totally 13 values we got in the table, so that my counter will be 13 initially. Okay, like that I need to take the counter value. If it is only 5 values, you can take only 5. If it is 30 values, you have to take 30 values. Got everyone? Any doubts?
No, sir.
Okay,
No,
now
sir.
clear accumulator. First, initially you have to clear the accumulator. Why? Because if you are going to perform any operation previously, that output will be stored in the accumulator. That is why that is the case. We are going to clear your accumulator. Now move C. See here, move is different, move C is different. What is the difference between move and move C? Instruction. When you are going to copy a content of a DPTR at A plus DPTR, if you want to copy it to accumulator, this instruction we are going to use move C A comma at A plus DPTR. Whatever the content in the DPTR means, we have loaded a table into the DPTR, that A plus DPTR into accumulator. Now we are going to load this table values in the accumulator. Okay, previously we are going to take move A comma so and so, whatever it may be, the 8-bit data that we can copy, but this instruction is different than compared to that instruction. That is why move C A comma at A plus DPTR we are going to use. Now move port 1 comma A. We are going to use port 1 here. That is why whatever the data in the accumulator, I am going to load it in the port 1. Now increment DPTR. Okay, it will be going to increment the values, incrementing the DPTR. After that, decrement jump if not equal to 0 R2 back. Now decrement jump if not equal to 0, R2 will be 32, it will not be equal to 0. So that decrement initially 13, now it will be 12, so that it will not be equated to 0, going to back. Like that it will be keep on rotating for 13 times. After it will be using for 13 times. After it will be going to S jump again. The program will be repeats. After once you are going to get from 0 to 360 degree, again if it will be going to back, again it will be going to start. ORG 300H. Initially we are going to start it with a ORG 00H. After that it will be going to jump to the ORG 300H. This is not 300, actually this is 30H. From 00 to 30 it will be kept for interrupts and polling purpose. They have left that memory location that we are discussed when we are going to discuss about interrupted polling. Okay, very basic about of this topic of this module that we can discuss later. Like this it will be work. Then this is the output we are going to get. Sinusoidal signal from 5 volts, it will be reaching maximum 10 volts, again 0, again negative peak, like that it will be keep on varying. Voltage will be from 0 to 10 I have taken. This is plus or minus 5 volts or 10 volts peak to peak, like that we can consider. At 30 volts, at 30 degree what is the value, at 60 degree what is the value, at 90 degree what is the value, 120, like that keep on it will be varying. You will get a sinusoidal signal. If you want still more smooth curve, here they had given to get a better looking sine wave, regenerate a table 13.7 for 2 degree angle. Each and every angle will be 2, means 0 degree, 2 degree, 4 degree, 6 degree, 8 degree, like that. If you want to perform, you will get a smooth curve of your sinusoidal signal. Am I right? Now we have get the degrees difference with respect to 0 to 30 degree. It will be taking some delay. If I am going to take 0 to 0, 2, 4 like that. It will be keep on varying for each and every step. Each and every step it will be going to increase. Okay, that is the assignment. You have to find the table. You have to find the table for each and every 2 degree 0, 0, 2, 4, 6 like that. Then you have to find all the values. Then you have to show the verification of that. Then you have to write a program, means counter value will be different and this table will be different. Other than that, everything is same. Then this will be changed. You will get exact sinusoidal signal with respect to 0, 2, 4 like that. You have to change the degrees. This will be same. Then you are going to write a program in the C. C means you are going to change these values. Okay, for that, for this for the present one, it will be as include register 51.h. This is the library function for your 8051 serial data. DAC data is equal to port 1. We are going to assign port 1 here. This is sorry. This is the port 1 what we are going to consider. Move P1 comma A, like that. Here we are going to consider port 1. Then void main unsigned character, that is wave values of 12. Sorry, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12 values we have taken. Totally 12 values we are going to fit it in the table. Then unsigned character x while 1 for x is equal to 0, x less than 12, x plus plus means this operation we are going to do like this in the C, in the single equation. For loop we are going to make, and digital to analog converter data is equal to wavelength of x. It will be closed. Okay, you will get a sinusoidal signal. This is a program using C programming. For Keel software for interfacing, maybe this will be you are going to use. This we are going to dump in the 8051 for the interfacing output. Okay. Now what you will do? Start the assignment. To get a better looking sine wave, generate a table 13.7 for 2 degree angle. Make a note of this. Have you make a note of this program? ಬರ್ಕೊಂಡಿದ್ದೀರಾ?
Yes, sir.
Okay, write down this waveform and C program. Then try for that 2 degree. In external, they will ask like that only. For every 2 degree, you have to find the value. After finishing this, start that assignment.
Sir, every 2 degrees values.
Yeah. For every 2 degree, you have to find. Then only you will get a smooth curve, like same sinusoidal signal. Yeah.
The table will be very long, sir.
ಅದಕ್ಕೆ ಹೇಳ್ತಾ ಇರೋದು ಮಾಡಕ್ಕೆ. ಶಾರ್ಟ್ ಮಾಡ್ಬಿಡಿ.
Okay.
2 ಪೇಜ್ ಅಲ್ಲಿ ಬರೀರಿ. ಅರ್ಧ ಈ ಕಡೆ ಅರ್ಧ ಆ ಕಡೆ ಬರೀರಿ. ಶಾರ್ಟ್ ಆಗುತ್ತೆ. See, the exam they will ask that only. This is just an example. To understand the concept, we are going to make this as a 12, 13 values. How many values you will get for 360 degree? 360 divided by 2.
180 values, sir.
Yeah. See, whatever the problem you will do now, you can scan the same for the assignment. I will give assignment for same question. You perform now, you can scan that only while submitting the assignment. Once again, don't write that. That is why I had make you to write that. Excuse me. See, in the next class, we'll discuss about stepper motor, interfacing of a stepper motor. Make it fast, everyone should show now. One by one, I
Sir,
will.
10 minutes, sir.
10.
10 minutes ಬೇಕು ಸರ್ ಸಖತ್ ದೊಡ್ಡದಿದೆ
ಮಾಡಿ